Hello, my name is Sam Dillander, and I'm one of the chemistry faculty here at Lord Fairfax Community College in Middletown, Virginia. This experiment is being video captured today for the Sloan Consortium class on how to teach online labs that's being taught by Dr. Jim Brown. For this assignment, I've written up the determination of density experiment, and I will post this on the course website. I will just show you highlights of this experiment today. I'm not about to read the whole experiment to you, but I'll just give you a few highlights, and again, the whole document is posted on the website. Now, density determination is a physical measurement of substances. It is a way to characterize a substance. So if you have an unknown and you're trying to characterize it, you can do a density determination, and I will show you that today for a liquid and a solid. Now, the way I've got this lab designed to engage students hopefully early on and get them to buy into this experiment, I have asked them to do two things before they even do the experiment. Here I've got a sheet of pre-lab questions, which I'm sure you probably cannot see. There's 3 questions though, and again, this is part of the experiment package, and this will be posted on the course website. So again, the intention is to get them thinking about density. What is density? How you calculate it? Again, the students would do this before they do the actual experiment, and this will be attached to the lab report that the student would do to send to me. Also, I've got a pre-lab demonstration. I'm not going to do that for you today too. I'm not going to do that today. So if you would like to do this, if you've never seen this before, the idea is you're going to take a 12-ounce can of both of a fully strength, so to speak, carbonated drink. A non-alcoholic would be preferable. And then a diet version of that. Get a pitcher of water, and you'll put both cans in separately into this pitcher of water. And the idea for students to see is, what happens to the cans? Do they both float? Do they both sink? Does one float, one sink, or nothing? So again, the idea is to think about density, which is mass per unit volume, to get them thinking about, again, what density is. So both the observation sheet and the pre-lab question sheet, if a student of mine was actually going to carry this lab out, they would attach both sheets to the lab report to be sent to me. All right. Now, I've got a data sheet that's attached. And now, again, this experiment can be done at home or anywhere students might be. And actually, I'm not trying to make an appeal or endorse any company, but eScience Labs have sent us a lab kit. So all these items that I'm using are from the eScience kit. Not the actual metal in it, but as far as the beakers, the Erlenmeyer flask, you can see the little electronic balance. We got the kit this week free of charge for us to, again, evaluate here at Lord Fairfax, and to give due, equal time, equal due. Hands-On Lab is actually sending us their kit too to evaluate. So you will need a small balance of some description, and this is the one that's in eScience Lab Kit. You need a series of beakers of something to hold water, a graduate cylinder. So again, all these were in the kit. All right, so we can do our liquid first. We'll turn on our electronic balance here. So the idea for density is, again, I might as well write on the board here, so I've got a board behind me. Density is mass per unit volume. And scientists usually express this in grams per milliliter. All right, so what we're going to do first is we'll take I'm going to use the smaller graduate cylinder because it fits on our little balance better. So I'm going to put that on the balance, and it weighs 8.4 grams. So the graduate cylinder by itself is 8.4 grams. So you can see with this balance, if you wanted more significant figures, you will not get that with this. All right, now, so now I'm going to add, this is rubbing alcohol or isopropyl alcohol or 2-propanol. So I'm going to add, and again, it doesn't matter how much volume you actually add. I'm going to probably make it easier, make the math easier for me. I'm going to fill up to the 2 mil mark, but again, it does not matter how much you actually add, because obviously as you add more volume, the mass goes up too. All right, so that's 2 mils. And the mass now is 10.1 grams. So this is the graduate cylinder plus IP8. All right, and we've added a total, again, of 2 mils. And by this graduate cylinder, again, you can only read whole units. So you subtract to get the mass of the alcohol. So you can put me on the spot here, see if I can subtract. So that's 1.7 grams, if I've done the math right there. So the mass is 1.7 grams, and the volume is 2 mils. So then to calculate the density, you would take, a calculator, or if you like to do things longhand, I'm going to use the crutch, use a calculator. So we've got 1.7 grams. We're going to divide that by 2, and we have a density value of 0.85 grams per mil. Now, as a student, I'm going to be lazy today, but as a student, I would encourage them to do 3 trials and take the mean of that, and then compare that to the true value of isopropyl alcohol. So again, this demonstrates how you would do a density measurement with a liquid. All right. Now, for a solid, what you will do, so we'll put this, that's for our liquid. Now for our solid, we're going to put it on the balance again. Well, I'll tell you what, why don't we can place, again, this is just aluminum, which is what I've got set for this experiment, but you could use any metal, but I'm going to just weigh the aluminum first. So again, the mass does not matter how much you put. All right, so we're going to have aluminum here as our next experiment. So again, we're doing density, which we know is grams per mil. So we now have 4.9 grams. Now, to get the volume, what we'll do is, again, this is just a regular graduate cylinder that was in our kit. I'm going to fill it up with water. Got a leak in my water bottle here, so let's correct that. All right, so I've got 4 mils of water in my graduate cylinder. Now I'm going to, by displacement, I'm going to put the metal in here. And the difference in the volume before and after the metal is the volume of that metal. So as luck would have it, it's actually 6 mils. And again, it may be hard to see the numbers on this graduate cylinder, but with the addition of the metal, so this is water only. So this is water plus metal. It's 6.0 mils. So you subtract that, obviously, that's 2 mils. So again, so you're going Now you would divide 4.9, which is the mass of the metal, divide the 4.9 by 2, and our mathematicians could do that in their head, but since I'm being recorded, I will use my calculator. So that's 2.45 grams per mil. So the actual value for this, so the true value is 2.702. So again, we have a fairly large percent error here, and the value for our liquid was 0.786. So you can see 0.786 versus 0.85. Again, we're not that close. So again, for the students, if I had students after doing this lab, I would have them do a second trial and a third trial, and then take the mean of their experiments, and then I would have them do a percent error, and all this is on the data sheet, which is in my packet. So as a final exercise for them to do to help them extend the lab, I've got some post-lab questions, and there's 5 questions have to do with specific gravity and various calculations that if you're given density and volume, determine what's the mass, and if you're given mass and density, what's the volume. So again, these exercises would help extend their knowledge. The exploration was doing the experiment, and the evaluation of the lab for them, they would be sending me a video of the lab this lab, plus they would send me their post-lab, their pre-lab questions, their data sheet, and the lab report. So this will conclude this lab today. Again, this video will be uploaded to the course website as well as the document itself. Thank you very much.